school and our department. Yeah, University of Wisconsin-Madison has a long history. We founded in 1848. Actually, we just celebrated the 175-year anniversary about 2 years ago. Right now, so we have 177 years history. In the university, we have 13 schools and colleges. So College of Engineering is one of the college. We have more than 26,000 faculty and staff, and our student body this year exceed 50K, like 50,000 students. Among those 50,000 students, we have around 37,000 undergraduate students and more than 10,000 graduate students. So roughly speaking, the ratio between graduate student and undergraduate student at UW-Madison is 1:3. And UW-Madison is viewed as a public ivy, is a flagship public school. So we rank very high among public schools. Now let's talk about the College of Engineering. So in College of Engineering, we have 8 different departments. But for the 8 departments, we offer degree and titles. Titles include the minors, certificate is 60. We offer 60 different degrees and titles. In ISyE, the student body have roughly this 4,500 undergraduate student and 1,500 graduate student. So total student body exceed 6,000. So our undergraduate program of ISyE ranked the top 10 among public schools, and the graduate program ranked number 13 among all public schools. Actually, most of our departments ranked in top 15 for many years among public schools. Here is our faculty in Industrial and Systems Engineering Department. Currently, we have 21 tenure-track faculty and 5 teaching faculty. So total, we have 26 instruction staff. And many of our faculty are world-famous experts in their corresponding area. And our faculty are really very well decorated. So we have many career awardees. Typically, career award is a top award given to the junior people when people start up their career. So the career award is offered by different federal agencies like National Science Foundation, Department of Defense, Department of Energy, and NOSHA. And we also have many fellows in the department. So fellows is mainly for senior researchers that become famous and contribute a lot in the corresponding professional society. So they will become fellows in the corresponding society. So you can see we have many fellows in ISyE. ISyE stands for Institute of Industrial and Systems Engineers, and 2 fellows in Informs, 4 fellows in HFES. HFES is Human Factor and Ergonomics Society, and 1 SME fellow and 1 SME fellow. SME is the American Society of Mechanical Engineers, and SME stands for Society of Manufacturing Engineers. So we also have 3 NE members in the department. This is the highest honor an engineer can receive in the United States. And we also have 2 National Academy of Medicine members. Those is the equivalent to NE, but awarded to the medical experts. So you can see our faculty are very well decorated in the department. This is the student body in our department. So right now we have 351 undergraduate students in the department and roughly 120 graduate students in the department. So typically our student body who are around 500 include both under and graduate students. And those students are very active in student organizations. So later I will introduce different type of student organizations. So this is our ranking. So both undergraduate program and the graduate program ranked number 5 in the nation among public schools. And for undergraduate program, if we count all the universities in the United States, we rank number 6. And for graduate program, if you count all the universities, not only public universities, we rank number 7. So we have been in top 10 for many years. So we are leading department in industrial and system engineering. So we have a very vibrant student life in the department. So in the department, for the research and the technological areas, we can be classified into 4 different fields. The first field is operations research, optimization, and analytics. So this is a classical area in industrial engineering, and the people doing optimal decision making and using advanced analytical methods, math models. And second area is advanced manufacturing and industrial AI. So people use data-driven and mathematical modeling approach for manufacturing process design and control. So we try to optimize like 3D printing process, in-space manufacturing process, and also to using industrial AI technology to achieve efficient operation of manufacturing processes for quality and reliability improvement. The third area is the human factors and ergonomics. So we focus on the human element in engineering system, how to design the system to reduce people's fatigue and improve people's trust and efficiency. So the fourth area is a unique area in our department is the health systems engineering. So traditionally we are very strong in this health system engineering. Essentially we look at clinical operation efficiency improvement and treatment planning optimization. So we have many famous faculty working in this area. In the department, we have many student organizations. So you can view this as the student clubs. So the student with a similar interest are very active in the corresponding student society. They often hang out and do collaborative learning. Yeah, so in these slides, we show 3 generic student organization. One is ISyE Connections. Essentially, it's a student peer mentorship program. So it is a platform. We can connect a current student with alums who has graduated from the program. And the alum will behave kind of like a mentor, provide job placement advisement, like include the course selection advisement advices. Another student organization is ISyE student chapter. Is the Institute for Industrial and Systems Engineer. This photo actually from an activity from ISyE student chapter. We also have active student chapter is a Society of Women Engineers. So those 3 student organization is kind of a generic student organization. So as long as you are in IE, you can join those sections, those organizations. So we also have a technological area specific student organization. So we have human factor and ergonomics society student chapter, Informs chapter. Informs chapter is mainly for operations research people. And we also have a student chapter for SME, Society of Manufacturing Engineer. So this is for people who are interested in manufacturing. So you can see those photos from the student activities. The job placement in our department is excellent because industrial engineering, industrial and systems engineering is a very diverse and broad area. So our students can find jobs in various different type of industry. Really is a broad range of companies we can go into. Particularly for our PhD student, roughly one-third of our PhD students will find a job in academia, become a tenure track faculty or lecturer in academic department. And another one-third will become a consultant, and another one-third become engineers in industrial companies. So you can see people can really find a job in a broad range of company from manufacturing, healthcare, consultant, and the entertainment and the logistic company. And for academia, we have a student, actually right now they're professors in Georgia Tech, Michigan, Texas A&M, Iowa State, Clemson, and many more. So actually, our department is viewed as a powerhouse of generating future professors. Yeah. So this is job placement. So next, if you join our PhD program, what is the life looks like? So in our department, the PhD student work very closely with their research advisor. Most students will have this weekly meeting with their research advisor, mainly work on the research project and work on technological area, conducting research that they are interested in. But in addition to the research experience, in our department, we will also provide the opportunity for improving communication skill and gain some teaching experience. So after you join the department, there's three key program milestones. Qualifying exam typically finish in first year, and then we have a prelim exam, and is a final defense. So later on in this program, if you have any question regarding the student life, like what it will looks like after you join the department, you can raise the question and we can provide the answers. Okay, this is a quick overview of the university and the department. So if you have any question, you can post it in the chat, or you can let us know.
Excellent, thank you. So Shu mentioned that we have 4 area groups within the department, and they also drive a lot of our research interests and focus. And so what we'd like to do next is to have each one of the area groups take a few minutes to introduce themselves and the faculty within them. So we're going to start with our operations research group, and that will be led by Professor Jonathan Mintz.
All right, good morning, everyone. Give me a moment here. Hope everyone's doing all right. Thank you, Shiu and Tony, for the introduction. So I'm gonna give a brief talk about our operations research group. So as Shiu mentioned, right, this is like our group that really focuses on these core kind of methodologies in industrial engineering. So optimization, stochastics, machine learning, the fundamentals of optimal decision making, that's really what we look at, both in the theory sense, the computational sense, as well as in the application sense. So why choose, if you're applying to do a PhD in operations research, why do operations research here at UW-Madison? Well, number one, we've got a great location. I'm going to try to highlight that a little bit more. We've got really great classes to cover all your basics, as well as several advanced topics. We've got a few experts in these. We've got amazing projects that we work on. We got, and obviously very biased here, but I think we have a very strong faculty in operations research, and I think we've got a very good relationship with our student mentees, who themselves are also fantastic. Plus, we like to have a little bit of fun along the way here as we go through our research. We really have a play hard, party hard mentality here at UW-Madison. So, uh, starting off with location. So I wanted to highlight this a little bit because sadly, right, you're sort of visiting virtually, but hopefully, um, once some of you apply and if you come to our in-person visit in the spring, you'll be able to see how beautiful the actual campus of UW-Madison is. So a lot of people, I don't think, realize that Madison's actually located on an isthmus between two lakes. We've got these gorgeous kind of water sites. We've got the historical Campanile Stadium, which is right outside where our department offices are, and it's a beautiful, beautiful area. In fact, this time of year is our chair kind of mentioned this last week, but we've got peak fall foliage, so we got like all four season here in Madison. It's beautiful all year round. Our department is located in the mechanical engineering building, but we're right next to the Wisconsin Institute for Discovery, which is itself a cool enclosed glass building with a micro ecosystem that even during Wisconsin January, which doesn't get too cold, right? It's still a very nice temperature outside. You can see kind of like a temperate rainforest inside, and there's like cafes and everything. It's absolutely gorgeous. And of course, the big selling point of UW-Madison's campus is Memorial Union Terrace, which is like a beer garden slash student union area that's located exactly like on the lakes where you can I enjoy an adult beverage or a non-alcoholic beverage of your choice, looking at the sunset, or take classes on sailing, which are actually discounted through the university. So if you ever wanted to learn how to sail or how to use any boats, it's a really good reason to come here. Moreover, we're actually in the midst of finishing construction on a new engineering building that'll be opening right next to where the department building is. And so by the time that you come here, hopefully some of those initial classrooms and laboratories will be set up over there, and you'll be able to take advantage of these new lounge areas and new student areas that are going to open up on the campus. So that should be great. Okay. In terms of classes, a lot of the core kind of engineering class or the core methodological classes of the department are taught by our operations research group. This includes all different flavors of optimization, from combinatorial to linear to stochastic, including looking at different forms of stochastics analysis. So we've got both a stochastics modeling and a stochastics fundamental class. We also have a focus on reinforcement learning, and we have a very strong dynamic programming course, as well as a core faculty looking at integer optimization. So lots of great methodological classes for you to choose here. And I'll touch on this a little bit later. I think UW-Madison is also a very unique place to do operations research, since not only do we have a strong OR group in the department, the university also has a strong computer science department, now I guess computer science college, as well as a strong statistics program historically. So you could use those classes to sort of supplement your operations research learning, which is not something that you find in a lot of institutions, right? A lot of other places might only have a strong industrial engineering department, might have an okay industrial engineering department, but bad computer science. We're really unique in that we have this trifecta that allows you to sample from all around these places, right? Moreover, oh, is everything okay there? Is there a question? Oh, no worries. Moreover, something that's unique about our OR group is we take a very heavy emphasis on making sure that our students are funded through grants. Even as hopefully the news is not too scary, we still have a lot of really great funded projects looking from more computational optimization to also applications in defense, applications in healthcare, applications in energy. And I'll talk about that a little bit more as I go through our faculty here, which we have fantastic faculty. So the core COR group comprises of these 7 or 8 faculty, as well as several faculty from other departments that have joint appointments with us, right? And as I mentioned, these go from statistics, computer science, and electrical engineering, and just shows kind of like the interdisciplinary nature of our department and the kind of research that we really like to do here, and expose our students to different ways of thinking and different types of methodologies to advance the research. So I'm going to go through the faculty very briefly. Some of these we'll hear more from, and then obviously some of these, feel free to reach out to them if the research sounds interesting and you want to learn more about their program. So the first one is Ozan Alagos. He does healthcare systems research. He teaches our healthcare decision-making class, and he really looks at more healthcare policy-oriented research, as well as looking at things related to sequential decision-making and Markov decision processes. We have Laura Albert. She really looks at applications using optimization for emergency networks as well as security. And recently, she's looking into machine learning. Professor Albert is fantastic. She does a lot of outreach for our department. She's also a former president of Informs, which is our, as she mentioned, kind of our big professional organization. So she's a great person, a super supportive person to work with. We got Professor Alberto Del Pia. He does more kind of fundamental research into theoretical integer programming optimization. He's unique in that he has his office in WID, so that building that I said with a nice hangout. Also, he's a great guy, and you should ask him if you talk to him about his preferences in coffee. He's very good about making espressos. Then we have Professor Jeff Linderoth. He's got a joint appointment in computer science. He does a lot of work on computational optimization, as well as recently doing a lot of work with applications in defense. He's a fantastic guy. He teaches a lot of our fundamental optimization courses. Also, he's an expert in human pyramid construction. Okay, so be careful. You don't want to be too close to him in the hallway. He might put you in a human pyramid. But he's a great guy. Then we have Jim Lutke. He is another optimization faculty member. He looks really at stochastic optimization methods and specifically optimization applied to power systems. And he also teaches several of our advanced optimization courses, including our stochastic optimization class. Then we have Professor Carla McKinney. She also looks more at theoretical optimization, and she teaches our combinatorial optimization classes and linear optimization classes. She's a super great person and looks at a lot of these fundamental concepts in algorithmic game theory and applications and networks. Finally, there's this guy, which is me, Jonathan Mintz. So my research is really looking at applications of reinforcement learning and machine learning and AI in healthcare and other human-sensitive contexts. So in terms of classes you take as a PhD student, I teach our dynamic programming course. The focus is on sequential decision-making and reinforcement learning. And I look at a lot of different problems from like fundamentals in reinforcement learning, like non-stationary multi-arm bandits, to like more recently, I have a couple funded projects looking at how we use large language models in sensitive healthcare settings to make sure that we can make a decision-making process more effective and get these models working for patients. Another more stochastics-oriented faculty is Xiaoming Xie. She looks more at fundamentals of reinforcement learning and applied probability. She does a lot of interesting applications, both in queuing as well as looking at infrastructure, but really more focused on kind of the fundamentals of the research. She teaches our stochastic modeling class. Then we have, last but not least, Professor Gabriel Zayas-Cabana, who you'll hear more about as he's going to introduce our healthcare group. And he really looks at causal inference and healthcare modeling, and also has a soft spot for queuing as well. And he teaches our healthcare systems class, and I think he's developing a stochastics class as well in the future. So be on the lookout for that. So he does a lot of interesting applications in healthcare optimization. So other than that, we have great student colleagues. We have a very active student Informs chapter that's one. Sorry, is there a question? Okay. So we've got a great student Informs chapter that's super active. They won an award even for their participation. They tend to attend our annual conference. They do a lot of great events. Like this is on the right here is a picture from a food drive event that they do every year. But they also host happy hours. In fact, like at this conference, they're on their own volition. We kind of let them set up a happy hour for Wisconsin alumni and Informs. And in general, we tend to be very student focused as faculty here. So this is a picture in the middle of me taking my alumni and student mentees out to dinner during Informs. And I think I'm not the only one. I think this is like something very common. We tend to really be focused on not just making sure that you produce high quality research and get top education, but that you feel like you're a part of the team, and that we really make sure we mentor you and not just treat you like a worker or another cog in the machine here. And moreover, we have great fun, right? So we don't try to take ourselves too seriously. We definitely have lots of happy hours, lots of different outing events. This is another picture from an OR group, Informs group event where they did a ropes course. And then here's the dangerous Jeff Linderoth constructing a human pyramid. If you want to look on LinkedIn for our faculty retreat, we also constructed another human pyramid. It's not mandatory to participate in them, right? And it won't affect your progress to a degree. But you know, we try to have fun here and make sure that we don't lose morale as we do the great work that it takes here, right? So I think I'll end it there and let the other folks introduce their area groups and leave it for questions later.
Great. Thanks, Jonathan. So, of course, if you have any questions, please feel free to put them in the chat. Our next area group that will be introduced is our healthcare systems group, and that will be led by Professor Gabriel Zayas-Caban.
Hey guys, let me go ahead and share screen. Can you hear me okay?
Yep, all good.
Okay, can you guys see the screen, Tony? Does it look, the screen is in presentation mode? Okay. All right. Well, thank you, Tony, for organizing. Thank you, Shiyu and Jonathan for the introduction. So I'll talk very briefly about the Health Systems Engineering Group, which is kind of a little bit of a cross-cutting across the different groups. So first and foremost, I always kind of like to have this mission statement, which was that we as a faculty, we try to be a national leader in health systems research and education. And we want to prepare graduate students who are in demand across academia, industry, and government, as Shiyu highlighted before, where our students end up. And we want our research to drive the field forward. We want to be that group that sort of people cite and refer to when we're talking about designing a better healthcare system. Okay. So why healthcare at UW-Madison? So 2 points I wanted to highlight. We have the highest concentration of health systems engineering expertise among U.S. industrial engineering programs. We're also internationally recognized for pioneering work in the field. And as an illustration of our success in this area, and this is something that Shiyu highlighted earlier, is we have distinguished emeritus faculty. So Patricia Bennett is a National Academy member. So is Pascal Carrion, Dennis Fryback, and Dave Gustafson. So these are some of the highlights from our group that have gone on to be nationally recognized. And the other side is that, as you saw in the highlights that Jonathan mentioned, we have a very strong, so there's a hospital system here. We have a very strong collaboration with UW-Madison School of Medicine and Public Health. So a lot of the faculty that I'll mention in a little bit, we have joint appointments with some department or some group in the School of Medicine and Public Health, with the School of Pharmacy, also with the School of Nursing. And importantly is that we have access to, just not too far from our department, maybe about a mile or so, with the UW University Hospital, which is about a 600-bed level 1 adult and pediatric trauma center, and has 127 outpatient clinics. And that seems to be growing with partnerships between UW Health and some local clinics as well. And in terms of industry partnerships, we are very close to Epic System, which is located in Verona, Wisconsin, which is, as you know or may know, is a global leader in healthcare software and industry north. So the best way to kind of introduce, so you're going to see these names several times over. You saw some of these when Jonathan introduced the Operations Research Group. So the best way for me to sort of organize, so they're here organized by domain expertise. The best way I can sort of introduce them is by highlighting projects that intersect, industrial systems engineering and healthcare. And right here, I have them organized by expertise. So on the human factors side, we have Professor Jackie Cha, Tony McDonald, our host, Ranjana Mehta, Doug Wiegman on implementation science. We have our research professor, research colleague, Todd Mulfenter, digital transformation, industrial analytics, Raj Virami, who is part of the manufacturing group. And then, of course, in operations research, there's Oz Alagas, Jonathan, and myself. So let me quickly conclude by highlighting some of these projects. I think that'll give you a better sense of the types of things that we do. And I apologize to my colleagues if I mess up some of these descriptions that are outside my area of expertise, but please don't hesitate to ask any questions towards the end. So on the human factors and economic side, so one project is Jackie Chow, who is our newest faculty member. She just got an NSF or recently got an NSF Career Award, and she's working on redefining skill requirements and evaluation interactions, dynamics between human, robot, surgical teams. So she looks at human-robot interactions. Professor McDonald, so Tony, he's has a recently funded project engaging patients with dementia with respect to decisions about transitions to non-driving. Professor Ranjana Mehta, who has done a lot of work in fatigue. So Ranjana, I'm really sorry if I messed that up. So developing AI-powered extended reality training for EMS delivery service. It's another project. On the operations research side, as Jonathan highlighted, probably one of our best known faculty here is Professor Alagas, and he's done a lot with cancer modeling, and a recent project is looking at comparative modeling of precision breast cancer control across the translational continuum. Just as a quick side highlight, Professor Alagas, this is a recent project, but he's also known for developing cancer models that are deployed at CISNET, which are used to actually develop policies for breast cancer screening, for example. Jonathan already introduced himself, so he's in the dynamic programming, reinforcement learning, AI, and he has a recent funded project on using reinforcement learning to personalize incentives for weight loss. And as for me, I've recently sort of shifted my attention to causal inference. And a recent project I'm working on is on evaluating the effectiveness of risk prediction tools that are deployed in the clinical setting to see if they're actually effective or not. And this is a recent project funded by Picori Award. And last but not least is our very dear colleague, research professor Todd Malfinter, who leads a center that's unique to UW-Madison, which is the Center for Health Enhancement and System Studies, or CHESS. And so CHESS is a very well-funded center, and a recent project that they just got has to do with opioid use disorder that was funded by NIH and the National Institute for Drug Addiction, a $6 million project. And I'll conclude by putting additional information about CHESS, which is, again, a big center with 34 full-time or part-time faculty that has developed, patient-centered technologies, is devoted to organizational change, has a total accumulated funding of $48 million. I think you can correct me if I'm wrong. And they work on things like opioid that I mentioned before, and it also collaborate, again, to highlight this cross-cutting aspect of health systems engineering with different departments across campus and with different universities outside of us. So that, I think, concludes. The last thing I'll point out, which is not in the slides, is because we're a cross-cutting kind of area group, our course requirements are very highly dependent on what you and your advisor decide. So we have PhD students who take courses from population health sciences, they take courses in statistics, they take our own courses in optimization, depending on what your advisor decides. I've had some students take courses in educational psychology. So that's, I think, the nature of the work that we do. So I'll stop right here. Tony, I'll leave it up for questions at the Q&A session, and then move on to the next.
Great. Thanks, Gabriel. So the next area group we'll talk about is our advanced manufacturing group, and that will be led by Professor Mike Beeler. So Mike, go ahead and take it away.
Yeah, awesome. So let me share my screen quick. So I'll talk about the advanced manufacturing group, and I mean, Jonathan already mentioned some great, points about living in Madison, all of that. So what I want to encourage all of you to think about, I think the PhD advisor kind of can make or break your PhD experience, and kind of Jonathan emphasized that as well. So we really make sure the students are at the center of what we do. So I want to use that kind of as a backdrop as I introduce kind of what we're talking here, and use the breakout sessions later to learn more about that. So broadly in advanced manufacturing and industrial AI, we're looking at a very broad spectrum of different innovations, digital technology. So we have people working on new sensor designs, advanced manufacturing systems, cybersecurity, robotics, automation. Of course, AI and machine learning is at the center of what we do, data fusion, combining different types of data together. But really, so this is kind of what we're looking at, a broad coalition of new technologies to improve manufacturing broadly, but other adjacent areas as well. Right. So what I think is unique to the group here is that we're looking at what are some of the engineering domain knowledge and some of the underlying physical principles that guide the industrial data analytics, right? And that might be different things, condition-based monitoring, how are machines responding to degradation, predictive maintenance and control related to that, real-time forecasting, cybersecurity aspects of that. What if cybersecurity translates into the physical domain? How would that impact the system, right? So quite broad area, but I think kind of introducing some of those area groups. I'll briefly go over some of those things. So what I'm interested in from a methodology side is mostly 3D machine learning, multimodal data fusion, and with applications in 3D, 4D printing. So what is 4D printing is objects changing their shape over time according to stimuli activation, right? So you can see a soft gripper that we manufactured in our lab, or those adaptive channel openings. So those are intended for GPU cooling. So you can imagine, depending on the temperature, you want more or less water going through, right? So when they're getting hot, you want the flow to get larger. Current designs look like this, right? So you have lots of slots, lots of sensors and actuators needed, and this device kind of could be naturally embedded inside of a pipe and will autonomously deform, right? So I think as you think about which schools you want to go to, I think that the key is really find a great fit with an advisor, right? So I've heard people compare that to finding a match in a marriage, right? So I think that that's probably a little bit big, but I think there's some truth to that. So really think about what would you be excited over the next few years, and I think also in manufacturing we have a very strong concentration, so it's not like you come here and there's only one professor you possibly could work with. No, we have lots of world-class faculty. But also we have the advantage of having, I think the student cohort size is important, right? So do you want to be part of a very large program, or do you want to rather have, more personal connections to your peers in the program? So those are some of the considerations I would encourage you to think about, right? So you'll see we have emails for all of our faculty here. So Andy, he works on data science for engineering processes and systems, focusing a lot on representation learning, multitask learning, Bayesian optimization, with very interesting projects in how do you design new nuclear engineering processes and do experimentation for that. Professor Liu, he's also here, so feel free to chat with him afterwards. Very interesting projects on broadly system informatics, data fusion, statistical learning. So you'll see here also some applications in nuclear, but very interesting work recently in healthcare and how do you apply some of the techniques to very challenging problems there. And so you'll see the links here. Professor Quinn, I think he's in the audience too, so feel free to pitch in. But great expertise in space manufacturing. I think very exciting photos here. You can see this is zero gravity testing of printing conditions, and I think scheduled to be deployed in space as well. So very exciting opportunities there as well. Professor Varimani, he also has a joint appointment with the business schools. Are really looking at what are some of the intersections, industrial analytics, also with a focus on how does this intersect with digital business transformation and strategies. Professor Zhou, you've heard from him earlier. Focus on industrial analytics for diagnosis and prognosis. So you can see one of his widely cited books here, focus on digital twins, Internet of Things. And he's the director of the IoT Systems Research Center, which has a lot of connections to industry and very interesting platform. Right. And so from our group, you've heard that a little bit before in a general introduction, but very great placement in academia, but also industry. And I think that goes back to this kind of student first, approach to say, kind of holistic mentoring of all of our students. So, that hopefully gives you a broad overview, and I think we'll be able to share this afterwards if you're interested in more detail. But I hope that gives you a kind of a overview and kind of initial starting points to talk to faculty in our breakout rooms.
Excellent. Thank you, Mike. So I'll take over from here. I'm going to give an introduction to the human factors area group. I know there's several faculty that are on here, so I will call on you to introduce your own research when we get there, because I'm sure that you'll do a much better job than I. So in terms of human factors and ergonomics, I want to take a few minutes. I know Shu kind of mentioned it at the beginning, but just to introduce the field if you're not familiar with it. So we're really focused as a field on making technology work for people. This can be on the cognitive side, it can be on the physical side, or it can be a combination of the two. We generally have a focus on things like reducing human errors, increasing productivity or safety or usability or well-being in healthcare contexts. And in addition to the cognitive side, the physical side, or combinations between the two, we also have a focus on organizational influences and overall systems influences. And that's an area that we're very well known for. So why should you look at HFE at UW-Madison? First thing is, and I think this is maybe one of the most important, we at this point have the highest concentration of human factors faculty working on AI and machine learning, and also the integration of these technologies into human systems. And I think we're quite outpacing the field on that. It's already been mentioned in a couple of the other talks, but our healthcare integration is something that we really benefit from here. It's many universities working with a hospital means driving several hours away to meet people there. Ours is just walking across the street. And in addition to the UW hospital that we have here, there's also several other research-oriented hospitals in the area that we've worked with in the past. Something unique about us as well is that we have a multidisciplinary collaborations across the department and across the university. So this has been mentioned a couple times before, but one of the very unique things about UW-Madison is that every single program here is strong. We're small in some cases, but in whatever classroom you walk into, you'll be learning from a world-leading expert, whether that's in human factors or industrial engineering or computer science, mechanical engineering, psychology. And so we really encourage our students to try to benefit from that as much as possible. And then it's been mentioned a couple times, not unique to any of the other area groups, but we've also been known to place our students in top universities and industry positions. We have some of the universities listed here. And then industry down below, and you'll notice a pretty substantial emphasis there on the big tech industry. I think one of the things that has been coming out as AI has been developed and deployed is an increasing need to focus on the role of humans and how they interact with AI. You'll see from several of the federal agencies and the points of emphasis from federal government research, humans and AI keep coming up together. So it's not just about developing new algorithms, it's about making them work for humans. And industry is increasingly recognizing that, and that's why our students are in such high demand from places like Apple and Google and Waymo and Meta and Amazon. As far as teaching, so one thing I don't think that has come up so far is that we do have a breadth requirement for all of our PhD students. So even if you're really thinking or leaning in a direction of advanced manufacturing or OR, you're very likely to, by virtue of that breadth requirement, have to take some classes in human factors. And so I wanted to highlight a few of those here and also kind of talk about how this fits with our faculty. So we do have a teaching faculty in our department, Hannah Silber. So she's teaching our graduate intro to human factors and then also design for disability and aging, and then a few other courses as well. John Lee and myself are more on the cognitive side. So we teach a few different classes, mainly on this idea of how humans integrate with machine learning process, whether that be in terms of AI or visualization or decision making. So all of those classes there are listed, and we'll cover those. Those I'll highlight, those tend to be ones that are good translations in terms of, a machine learning process is a machine learning process, whether you're using human data or data from a manufacturing process or a healthcare process as well. So a lot of those ideas will apply across the board. Rob Radwin and Jackie Cha both teach our occupational ergonomics and biomechanics course. This is a little bit more on the physical ergonomics side. Doug Wigman teaches our human performance and accident causation. This is very much a sort of systems view on errors in human performance. So another one of those classes that's very broadly applicable to just kind of getting that perspective around systems and how they work together and how they produce both positive and not positive outcomes. And then Ranjana Mehta teaches our human factors design and evaluation. So this is getting into the design process and how to integrate humans through that as well. One of the reasons I mentioned we're so strong in AI is not just our research, but we also have the ability in the department to teach special topics courses, and this is an area that helps us keep our curriculum fresh. So we oftentimes will teach some of these kind of cutting edge courses, and then as they become more refined, they'll become full-time courses. But it also gives us that freedom when new things come out or we have a new edition of ChatGPT or something like that, we can immediately integrate it into our curriculum. So just a couple examples of that that have been offered recently. We've had a course in human AI teaming, the mind motor machine nexus, which is looking at how machines like vehicles or manufacturing robots interact with humans, both in a motor and a cognitive sense. Also, we have a course on AI for people, and this is again kind of thinking about integrating AI, and then applications and implications of generative AI. So I want to move on and just give some brief introductions to our faculty and their research focus. So Jackie Cha, like Gabriel mentioned, is our newest faculty member in the department, and she has a primary focus in healthcare, but also some overlapping in terms of training, surgery, cybersecurity, and clinical decision support. And is working quite a bit in terms of telerobotic surgery, is also working with our Department of Surgery and Department of Urology as well. John, I know is on the call. So John, do you want to take a minute to introduce yourself?
Sure. Yes. So I'm John Lee. I'm a researcher focused on cognitive engineering, more of the human cognitive side rather than the physical side of interacting with technology, particularly technology that is either AI or automation. So for many years, I've looked at automation in driving and even in maritime system ships. I've also looked at how technology mediates attention, changes what you pay attention to in the world. And in this context, looked at issues of driver distraction, and I'm continuing that work looking at how vehicle automation combined with in-vehicle infotainment systems influence driver distraction and risk associated with that. A lot of my research for many years has looked at the interaction between people and technology and what causes them to use it or not use it. And trust is one of the major issues there. Some of the current projects I'm working on, one is looking at uncertainty resolution and trust calibration with AI. Another is looking at how AI affects education outcomes at the individual level, and then how those propagate to the group or classroom level, using agent-based modeling to simulate that. And then the last one, I'm collaborating with Tony on a project funded by NSF, looking at how you align the vehicle with the person's goals and then align the person with the vehicle's goals. The vehicle might be trying to optimize traffic flow, for instance. So that's a bidirectional alignment between drivers and automated vehicles. So look forward to talking with those of you who might be interested in some of these topics.
Thanks, Sean. Okay, so I'm next. I'm Tony McDonald, as you have been aware throughout this talk. So my work right now kind of has two different areas of focus. One is more along the lines of the intersections between transportation and healthcare. So we have our own custom cloud-based driving data collection infrastructure, kind of an Internet of Things with driving data. And we've been using that for a couple different applications. One is more along the lines of driving decision making, particularly in light of either illness or acute or chronic illness like Alzheimer's and related dementias, or acute illness that results in a hospitalization. How do you return to driving after that? And then we've also been interacting with insurance companies as well to try to look at, are there opportunities to improve driving safety based on providing drivers intelligent feedback. That's an interesting project because it involves a collaboration with Jonathan Mintz. So we're overlapping between human factors and AI there. The other area of my research is a little bit more theoretical in nature. So one of the challenges that you've probably read about in the news with automation is that as automation is trying to look at human intent and making plans based on what humans do from a physical sense, there's often some conflicts there with what humans are actually trying to do from a cognitive sense. So we're trying to look at developing novel models of driver behavior that actually track cognitive processes over time. So we can look at not just what decisions a driver or a human interacting with automation made, but also why they made those decisions. What was it about their beliefs in the system that led to that? And then also tie that back to things like trust in the system or situation awareness as well. So that work has been sponsored by a collaboration between National Science Foundation and also some industry funding from Waymo as well. So Ranjana is on the call, so I will give her a minute here to introduce her work as well.
Thanks, Tony. Hi, everyone. So my research is in neuroergonomics. Neuroergonomics is the study of brain and behavior at work. A lot of research in our lab focuses on understanding the mechanism driving human behavior and then utilizing the knowledge that we gain from those mechanistic insights to build support systems or decision support systems for individuals to be supported when they are interacting with these socio-technical systems. So some of the research methodologies that we use are neuroscience principles, physiological computing, collaborated with Tony and other faculty in other institutions on predictive analytics, as well as code design research approaches. The core of our work is really looking at humans in extreme environments or extreme conditions, and those conditions could be intrinsic to the human, so states of stress or fatigue, or could be extreme in environmental conditions such as in disaster response or in high stakes environments like in offshore oil and gas. So we have several projects that we look at. They are funded by different agencies looking at operator readiness in extreme environments, understanding markers of human performance under different conditions, focusing also on embodied AI human teaming. So really looking at the physical mind-motor interactions with robotic systems or AI systems and seeing how human behaviors modify in response to those interactions. We have also been dealing with training for first responders using augmented reality or virtual reality training systems. And finally, in developing intelligent decision support tools for allowing workers to make decisions regarding their own fatigue or stress management. Thank you.
Thanks for joining. Okay, next faculty is Rob Bradwin. So Rob actually has a dual appointment in biomedical engineering. He's actually the founder of that department. So has quite a few collaborations there and also with mechanical engineering and computer science as well. He works a little bit more, like we said, on the physical side of interactions, but also integrates things like computer vision tools, as well as a new method and approach to this kind of physical ergonomics. And then also, as mentioned here, is integrated reinforcement learning as well, looking at things like worker capabilities and optimally assigning tasks as well. And he's collaborated across not just different areas in the university, but also both on the federal funding side and then with GM and Boeing on the kind of industry side as well. Okay. So our final faculty, and Doug, I saw you on here as well. So it's Doug Wigman. So Doug, I'll give you a few minutes here to introduce yourself. Sorry.
Okay. Yeah. Thank you. Good morning, everybody. It's a pleasure to be here and chat with you a little bit, share with you a little bit about the work that my students and I do in my lab here. So generally, as mentioned before, I teach the accident investigation course, which is really a system safety class. And my area is more broadly in system performance. So I'm interested in system safety, system reliability, efficiency, and quality, and the human factors associated with those, so the human component of that. And so many times in those processes, one of the contributing factors to accidents or quality escapes from factories or breakdowns in high reliability systems has to do with some form of human performance issue. Some human in the loop did or didn't do something that they potentially should have done to keep the system operating safely or reliably. And so rather than blaming the human for the mistakes they make or the things they do, we go in and try to understand how the work system is impacting their behavior and how can we redesign the work system to increase the likelihood that they do the right thing and make right decisions and so on. And so a lot of the work I do is in studying accidents and incidents and then developing tools that can be translated into the field for people who actually do this work to use, because PhDs out there aren't necessarily doing these investigations. It's people with bachelor's degrees or master's degrees in different disciplines who are now being assigned to try and figure out why the human on the line or human on the flight deck or wherever they may be did or didn't do something. And so in my lab, we develop tools to help support that activity and then do research to validate those tools, if they're reliable or they're consistent, in order to help people do a thorough and credible human factors investigation of those events. So that's one element of my work, is really getting into post-event investigation and system redesign. The other element of my work is more prospective or proactive. It's not waiting for accidents to happen. We're putting in solutions to solve problems that are there. And many of those cases right now involve the implementation of strategies to improve clinical decision-making through the use of AI, which you've heard of over and over again. It's becoming more and more prevalent. These are over in the UW Health System. We're working with some emergency room physicians to look at how to use AI to rapidly diagnose deteriorating patients, to flag patients who may be at risk for certain events when they leave the ER. And so our role is not to develop those models. The models have been developed and validated on the data, and now we're rolling them into a clinical setting. And so now we're observing the extent to which the promises of AI manifest themselves and why or why not, right? And so it's kind of the same. Has the process changed? Has the system improved? And it should, given all the elements and all the math, right? But then when you actually look at the process and you study it, you realize that some things are not working as well. And many times it's because there's a human in there who's also intelligent in making decisions and deciding when and where, how to use the AI and so on. And so that's another element of the work I do is to try and figure out and help redesign systems to get people to, again, incorporate and integrate and ensure that these interventions that we implement in the real world setting actually produce the return on investment that we hope they will. And so I have students who basically do a lot of work in the ED, in the OR, observing teams, collecting data, interviewing patients, interviewing clinicians about all of these types of topics. Yeah, so in any case, I'll stop there and I'll hang out too if there's time for open discussion. Thanks, Tony.
Great. Thanks, Doug. So just to kind of close the loop here, I think the last thing that really makes us unique as a human factors faculty is that we really do cover all aspects of this human system, from the organizational side to the physical side to the kind of neural and physical side, as well as the cognitive side too. So you'll very much get a very comprehensive education in human-centered AI and just in general in human factors from our department. Okay, so with that, I wanted to take a brief break here before we dive into some application logistics. So if you do have any questions, please drop those in the chat, and I'll pause the recording for now, and we will address those questions as they come up. So we'll say we'll take about just a 5-minute break here. So at about 10:12 Central Time, we'll restart, or 12 minutes past the hour, we'll restart. Okay, and then I'll share my screen. So I wanted to actually not use slides for this and instead just illustrate it through links. So I'll post these links here in the chat momentarily, but just in terms of getting here, just a Google search for ISyE graduate admissions, and then just the fourth link down here is this first page I'll show you. So this is what the top of the page will look like when you navigate to this link. And if you scroll to the bottom of this link, you'll see something that looks like this. And if you click on how to apply, these will give our deadlines and then also our application requirements down here. So a couple things with application requirements. There's overall graduate school requirements from the university level. So if you click on this link here, it will open up the second link that I will post in the chat here. So these are the general requirements for the graduate school at the university. And I won't go through these verbatim, but this is something that you do need to check as you are going through and preparing your application and making sure that you meet these requirements. Even if you find a faculty who's very enthusiastic about working with you and the graduate admissions committee reviews your application favorably, if you do not meet these requirements, you cannot be admitted to the university. So make sure that you're checking these and going through this process. There's some links here if you have questions, and you can address them more to the graduate school. So if there's specific things on this, it'd be better to reach out and ask the graduate school. In terms of our specific requirements for our application, we want to see a list of 3 recommenders. These can come from any source that you feel appropriate. I think the very best and most compelling letters often come from pure faculty or faculty at other institutions. They often have a better insight into what a successful PhD student looks like and how that might map with your skills. It's far better to have a letter of someone that knows you well and gives sufficient detail rather than a letter from, say, an NAE member that you've met once. This is just doing this as a favor, that doesn't really know you well and can't really comment a whole lot on your application or your preparation and things like that. It is also okay to have letters from, say, industry managers or things like that, although, like I said, those are typically slightly less useful than folks in your academic circle. The second thing will require for your application is your statement of purpose. So the statement of purpose, we want you to explain kind of why you want to be here at UW-Madison, why you're interested in our program, faculty members that you're interested in working with and doing research with. I think we also, as a US-based institution, we don't consider identity characteristics at all in our admissions process, but we are interested in your story, where you came from. PhDs are never a linear process, so there's going to be some back and forth, some ups and downs and things like that, and knowing how you've addressed that in your life previously is very useful, and your level of resilience and things like that are also things that we take into account and consider and would reflect favorably. Test scores, we mentioned, or I showed briefly from the graduate school, there's some test scores, English language proficiency scores, but we do require right now the GRE for our program for this application cycle. If you have a hardship related to the GRE, make sure you speak with faculty, particularly if you find a faculty that's interested in working with you. And we do have a process to waive the GRE if we feel your academic preparation is sufficient and that you have a hardship that would be encountered by having to take and submit the GRE. So like I said, make sure you communicate that with individual faculty as you're preparing to work with them. And we have a process, like I said, for waiving that. And then we do require at least an unofficial transcript for all of your degrees with your application. That's another thing that is very useful as we go through and process things. So that's kind of the preparing of the application and the different components. As far as evaluation of the applications, we have a committee focused on graduate admissions assessments in the department. And that committee has members from all of the area groups within the department. What we do is after the application deadline cutoff, so this year, December 1st, is that we review all the applications together. We have a holistic assessment that we do on the applications. So like I said, this considers your background, your preparation, your match potentially with faculty and research areas. It can also consider things like your background in how you've handled things in terms of challenges in your life and things like that. So it's looking very broadly, and our focus is to identify candidates that we feel will be very successful in the program. So after that graduate admission assessment, you will also be evaluated by individual faculty. So most of our admissions in the department are done through a direct process where you know exactly who your advisor will be, and that person will be involved in your admissions process and assessment as well. So it is important to be thinking about or finding advisors. We have a second sort of pathway to admission, which is conducted at sort of a group level. This is often used in cases where we have multiple faculty that are interested in working with you, or you need more time to kind of figure out which of the precise faculty that you would work with from a group that's interested. And again, that's assessed by the overall graduate admissions committee, and we have some portion of our admissions come from that. It's called the GARC admission process. So the majority is direct admission, but there are some cases where we have GARC admission. And again, that's a case where there's multiple faculty. And as you've seen from all the presentations, being collaborative and working together and having a collegial environment is very important to us, both from a faculty to faculty and also faculty to student interaction. And so that GARC process allows us to have more time to kind of assess and identify students that we feel are very strong, but also that we need more time to figure out what the best fit is going to be. So throughout the rest of this call and as you're moving forward, As Mike hinted at in his presentation, it's really important that you're interacting with faculty, understanding their research interests and your interests, and looking at how those fit together. So use these links to find more information and also get a link into the actual application and beginning that process. Do not hesitate to reach out if you have any specific questions. You may hear from me in that process. You may also hear from our graduate admissions coordinator, Pam Peterson. She's also responsible for kind of managing these more kind of logistical questions about when and where and how some of these things are submitted. So you can reach out to me as a direct contact, and if there's a question that is more appropriate for Pam, I'll connect you with her. Or if you know that the question is directly applicable to Pam, you can reach out to her. So this is my email address, and you can use this, like I said, for context on that. Okay. So any questions that raised, or were there any that I didn't address as far as the application process? Okay. So as our next phase of this,